the operating characteristic function. There are two actually important function as far as the sequential testing is concerned. One is OC function or operating characteristic function, and another is ASN function, that is nothing but average sample number function. So the first we will discuss is operating characteristic function, also known as OC function. Now let x be a random variable under consideration which possesses probability density fx theta. The fundamental form of PDF is known to us. So for example, if I am talking about the binomial distribution, then we know the fundamental form of the PDF of binomial distribution. So the fundamental form of PDF is known, but the values of the parameters are unknown. So the distribution of x is defined by the parameter theta, because theta is nothing but the indexing parameter, and therefore the distribution of x is defined by the parameter theta. The probability that process will be terminated with the acceptance of h naught depends only on the distribution of x, and thereby depends on the parameter theta. As I just said, theta being an indexing parameter, the distribution of x is going to depend upon the parameter theta, and therefore the probability that process will be terminated with the acceptance of h naught, which naturally depends on the distribution of x, and therefore it also depends upon the parameter theta. That means the probability or the process will be terminated and we are going to accept the hypothesis. Probability of such event depends upon the parameter theta. उसका मतलब ये आता है. And therefore generally we denote this OC function by L of theta, because as I said, it's a function of parameter theta, and therefore this depends upon the theta, इसलिए इसको generally denote किया जाता है L of theta, that is nothing but a function of theta. So OC function, that is L of theta, is a function of theta. Therefore L of theta, which is nothing but the probability of terminating the process with the acceptance of h naught. So OC function में इतना ही नहीं लिखना है, probability of terminating the process. This decision is also important. As I said, probability the process will terminate with either you take a decision that you are going to accept the hypothesis or you are going to reject the hypothesis. Okay? So L of theta represent one of that criteria, that is acceptance of h naught. So in other words, L of theta is nothing but probability of terminating the process. ये तो ठीक है, but with the acceptance of h naught. So that is the meaning of L theta. This L theta is called as operating characteristic or OC function. Okay. The function L of theta can be plotted against the different values of theta, taking theta on x-axis and L of theta on y-axis. So for the different values of theta, if we compute L theta, then you will have a series of values of L theta for different values of theta. So if we plot the curve by taking theta on x-axis and L of theta on y-axis, then that curve is called as OC curve. This is the general form of the OC. Generally we will get this type of OC curve. Of course we are going to discuss this OC curve in detail in SPRT, but this is basically the general form of OC function in sequential testing. Let omega be the parametric space of the parameter theta such that omega, which is equal to omega naught union omega 1. For testing the hypothesis h naught, theta belongs to omega naught, against h1 theta belongs to omega 1. So this is the hypothesis that we are considering. Right? Theta belongs to omega naught and theta belongs to omega 1, which is the alternative hypothesis. Here we are considering a sequential test function which eventually terminates. That is, we are taking either of the first two decisions, because the process will terminate only when you either accept the hypothesis or reject the hypothesis. So that means we are taking either of the first two decisions, that is acceptance and rejection, with full certainty, then only this sequential test function which eventually terminates, जो बोल रहे हैं उसका मतलब है full certainty की I am talking about, right? Therefore, probability that rejecting the hypothesis H naught will be equal to 1 minus L of theta, because we have considered L of theta as probability that the process will terminate with the acceptance of the hypothesis. So अगर मैं rejection of hypothesis की बात कर रहा हूँ, of course the process is going to terminate, but now I am talking about rejecting the hypothesis H naught, then that will be denoted by 1 minus L of theta, where L of theta is nothing but OC function which denote the probability of accepting the hypothesis, and therefore 1 minus theta is nothing but probability of rejecting the hypothesis H naught. Naturally, again, if you are going to accept the hypothesis or if you are going to reject the hypothesis on the basis of ultimately the sample, wrong decisions are again possible, because please remember that we are taking a decision on the basis of a sample, तो wrong decision यहाँ पे भी possible है. OC function is very closely related with the power function of traditional testing of hypothesis problem. I hope you remember what is meant by power function, which is denoted by beta delta theta, right? हम लोगों ने उसको लिखा हुआ है, beta delta theta will be equal to either alpha or equal to 1 minus beta, depending upon whether hypothesis H naught is true or depending upon whether hypothesis H1 is true, right? So this OC function is very closely related with the power function of traditional testing of hypothesis. For any parameter theta which is not consistent with H naught, the power of the test is probability of rejecting the hypothesis H naught when theta is the true value. So what does it mean? See what I have said here. For any parameter theta which is not consistent with H naught, मतलब H1 is true, I am talking about H1 is true, the power of the test is nothing but the probability of rejecting the hypothesis H naught when theta is the true value, where we are saying that theta is not consistent with H naught. In other words, what I am saying, theta is not consistent with H naught का ही मतलब है H1 is true, and what we are taking a decision, we are rejecting the hypothesis H naught. In other words, this is the correct decision. If I say that parameter theta is not consistent with H naught, in other words, it means that H1 is true, and what I am saying here is that probability of rejecting the hypothesis H naught, that means I am rejecting the hypothesis. Rejecting the hypothesis H naught when H1 is true is nothing but power of the test, and that's what I have written. The power of the test is probability of rejecting H naught when theta is the true value which is not consistent with H. So therefore this is nothing but the probability of taking correct decision, which is nothing but power of the test also. Thus probability that rejecting hypothesis H naught when H1 is true in terms of OC function is nothing but 1 minus L theta. हम लोगों ने अभी प्रीवियस स्क्रीन पे देखा था 1 minus L theta is nothing but probability that we are going to reject the hypothesis H naught. अभी उसमें एक additional sentence मैंने डाल दिया है when H1 is true. So if we consider this whole statement, this is nothing but rejecting the hypothesis H naught when H1 is true. Now we know that rejecting the hypothesis H naught is nothing but 1 minus L theta. And when I am saying that when H1 is true, इसी का मतलब होता है when theta belongs to omega 1, because H1 is nothing but theta belongs to omega 1. In other word, this is nothing but the correct decision, 1 minus L theta when theta belongs to omega 1, and this is nothing but power of the test, right? So this OC function basically then gives us the probability of making a correct decision. So thus for any parametric point theta, probability of making correct decision can be obtained immediately from the OC function. right? So whether either you are accepting the hypothesis or rejecting the hypothesis, OC function will give us the accuracy, or it will tell us how correct that particular decision is, what is the probability of taking that correct decision, that is given by the OC function. So there are two possible decisions, and there are uh, two possible nature of the hypothesis also. So when I am saying that when theta is consistent with h naught, इसका मतलब होता है कि h naught is true. When theta is consistent with h naught का मतलब हो गया theta is true, h naught is true. And L theta, you know, that is nothing but probability of accepting the hypothesis h naught. L theta का मतलब है probability of accepting the hypothesis h naught. 1 minus L theta का मतलब है probability of rejecting the hypothesis h naught. Now when I am saying that theta is consistent with h naught, उसका मतलब ही होता है theta belongs to omega naught, इसी का मतलब हो गया h naught is true. In such cases, L theta will represent the probability of making correct decision. 1 minus L theta will not represent, but only L theta will represent. Why? Because h naught is true, and L theta represent the probability of rejecting the probability of accepting the hypothesis h naught. So in other word, when I write down a statement for this situation, the situation is when theta is consistent with h naught and L theta is nothing but probability of accepting the hypothesis h naught. अगर ये दोनों situation को मैं combine करता हूँ, then I will have a probability that the hypothesis h naught is accepted when hypothesis h naught is true, and that is nothing but the probability of making a correct decision. So in such situation, L theta will represent a probability of taking a correct decision. On the other hand, if theta is consistent with h1, उस केस में probability of making correct decision हो जाएगा 1 minus L theta. So जैसा power function में था alpha and 1 minus beta, similar concept is here. यहाँ पे L theta will represent a probability of making a correct decision when h naught is true, and 1 minus L theta is the probability of making a correct decision when h1 is true, right? So that is what I have written. On the other hand, if theta is not consistent with h naught, that means if h1 is true, that is theta belongs to omega 1, then probability of making a correct decision is 1 minus L theta. So L theta probability of making a correct decision है या 1 minus L theta is a probability of making correct decision, ये depend करता है true nature of the theta, true value of the theta. If theta belongs to omega naught, then this is a probability of making correct decision, and if theta belongs to omega 1, that means the alternative hypothesis, then probability of making correct decision is 1 minus L theta. Naturally, probability of making a correct decision हम प्रेफर करेंगे हायर साइड में रहे, मतलब वहाँ पे गलती ना हो, एरर्स ना हो. वो कैसा होगा? If the probability of making correct decision is high, and therefore we prefer higher values of L theta when your null hypothesis, that is theta belongs to omega naught, is true. That means we prefer a higher value of L of theta when theta belongs to omega naught, whereas when theta belongs to omega 1, we prefer low value of L theta. That means we prefer high value of 1 minus theta, L theta, right? So higher value of L theta हम तब prefer करेंगे जब theta belongs to omega naught है, and lower value हम तब prefer करेंगे when alternative hypothesis is true, right? In other word, 1 minus L of theta की higher values को हम लोग prefer करेंगे. So that is nothing but, you know, the OC function. Now we will discuss the average sample number in SPRT. Now we know that in sequential testing, or for that matter in SPRT also, the sample number or the sample size is a variable, it's a random variable, right? That means if we repeat the same experiment number of times, the sample number or the sample size may vary, and that is because it depends upon the certain criteria, whether to continue the sampling procedure or whether to terminate the sampling procedure with the acceptance or rejection of the hypothesis. That means the sample number or the size of the sample is a random variable. Now by size of the sample n, it means that the number of observations required by the test procedure in sequential analysis. So as I already mentioned, this size is a random variable. That means if a test procedure is repeated number of times, then this n will take different possible values. The average value of this random variable, that is n, is called as average sample number, that is ASN function, which is generally denoted by En theta, which is naturally a function of theta. Now to obtain an approximate expression for En theta in the case of SPRT, let us take the help of expectation. Now we know that by definition of expectation, we have expectation of n naturally will be equal to 1 into probability that n equal to 1 plus 2 into probability that n equal to 2 and so on, right? In other words, that is nothing but probability that n equal to 1 plus probability that n equal to 2 plus probability that n equal to 2, then plus, since this function is repeated 3 times, therefore probability that n equal to 3 plus probability that n equal to 3 plus probability that n equal to 3 plus so on, and therefore we can collect the terms of n equal to 1, n equal to 2 and n equal to 3 in the first bracket, and therefore we will have in the first bracket we have probability that n equal to 1 plus probability that n equal to 2 plus probability that n equal to 3 in the first bracket, then plus, now n equal to 2 is repeated 2 times, out of that one function I have already included in the first bracket, and therefore the remaining probability that n equal to 2 is included in the second bracket. So in the second bracket the terms will be probability that n equal to 2 plus probability that n equal to 3 plus probability that n equal to 4 and so on. In other words, it means that we have probability that if I consider the first bracket, then it is n greater than equal to 1, that means probability that n greater than equal to 1 plus, if you observe the second bracket, all the terms where n is greater than equal to 2. In other words, that means probability that n is greater than equal to 2, and so in the third bracket we will have probability that n is greater than equal to 3 and so on. In other words, this is nothing but the summation of probability that n greater than equal to m, where m varies from 1 to infinity. So let us mark this equation as equation 1. Now I have told you number of times, in sequential probability ratio test, or for that matter even in sequential testing, size of the sample is a random quantity taking any value from 1 to infinity. Now let us consider capital N be a very large positive integer such that probability that n greater than equal to n is neglected. That means probability that small n is greater than equal to capital N, this probability is equal to 0. In other words, we shall assume that n is less than capital N. Therefore, z1 plus z2 so on up to zm, that is summation zi, where I varies from 1 to m, can be bifurcated in two parts, which will be equal to z1 plus z2 so on up to zn, plus in the second bracket the terms from n plus 1 up to m. In other words, that is nothing but zn plus 1 plus zn plus 2 plus zn plus 3 so on up to zn. Suppose this is equation 2, where of course we know that zi is nothing but log of f of xi theta 1 divided by f of xi theta 1. Now if we take expectation of this particular expression, then we will have n into expectation of z, which is equal to expectation of z1 plus z2 so on up to zn plus expectation of the second bracket. We know that summation zi is nothing but expectation of n into expectation of z. So using that, I have written here n into expectation of z. So let us mark this as expression 3. Now we also know that z, which is equal to log of f of x theta 1 divided by f of x theta 0, where z is also distributed similar to zi, where I is greater than m, and zi is distributed independent of n. Naturally, if we write expectation of then z n plus 1 plus z n plus 2 so on up to zn, that value will be equal to expectation of n minus n into z, which is equal to n into expectation of z minus expectation of n into expectation of z. So if we put this value in equation 3, then we will have left hand side we have n into expectation of z, which is equal to, this is the first bracket, plus the second bracket was expectation of z n plus 1 plus z n plus 2 so on up to zn. We will replace this expectation by this particular expression. So if we put that value, then we will have plus n into expectation of z minus expectation of n into expectation of z. Naturally, n into expectation of z get cancelled, and the remaining term, that is, we have expectation of n into expectation of z, which is equal to expectation of z1 plus z2 so on up to zn. Naturally, therefore we can now write down expectation of n equal to expectation of z1 plus z2 up to zn divided by expectation of z. So let us mark this as expression 5. Now this expression 5 is nothing but the Wald's equation, and if theta is the true value of the parameter, then Wald's equation can be written as expectation of n. Theta here is included to indicate that theta is the true value of the parameter, so it will be equal to expectation of Sn divided by expectation of z, again which is a function of theta, where Sn is equal to z1 plus z2 so on up to zn. Now if we assume that the excess probability ratio, that is p1 upon p0 over the boundaries of a and b at the termination of sequential process is neglected, termination of the process का मतलब है either we are going to accept the hypothesis or reject the hypothesis. If that excess probability is neglected, then the random variable z1 plus z2 up to so on zn can take only two values, that is log a and log b, with probability 1 minus L of theta and L of theta respectively, and therefore we can write down expectation of z1 plus z2 up to zn can be written as log of b into L of theta plus log of a into 1 minus L of theta, where L of theta is nothing but the OC function of the SPRT. So using equation 6, now if we put the value, then expectation of n will be equal to log of b into L of theta plus log of a into 1 minus L of theta whole divided by expectation of z. This expression is nothing but the ASN function of the SPRT, where naturally expectation of z depends upon the probability density given in the problem. The constants a, b and OC function, that is L theta, are obtained by our expression for a, b and L of theta shown on the screen. So this equation, that is expectation of n, will be equal to log b into L of theta plus log a into 1 minus L of theta divided by expectation of z is ASN function of SPRT.